Hey gang, so this is our quadratic pre-test video. So grab your dry erase board, marker, and a rag, and let's get going. Alright, so the first thing I'm going to do is remind you about domain and range. So let's say I have a situation, and let's say my graph looks like this. And I'll mark off 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, I didn't mean for that to go 6 to 6. Well, let's make this 5 and 6. I know it doesn't look like it, but let's just say that. So if I want to know the domain, domain is the x. It's how wide is it. If I want to know the range, that is how tall is it. So what I want to do is I want to look at this and I want to say, how wide is it? Well, it starts here, and if I draw, like where this dot is, if I draw a line down all the way to the x-axis right here, that's 0. Here's where it ends, so let me draw a line right here, that's 6. So it goes between these two boundaries here from 0 to 6. So my domain goes from 0 to 6. It's every single value in between here, all these numbers. This is where my graph is. So domain is the x, so less than or equal to, less than or equal to. Now let's look at how tall it is. Well, how tall it is, this is the highest point right here. It goes all the way up to here, which in our situation, I guess we really should have said 1, 2, 3, 4, 5, 6, so it goes up here to 6. And then it goes all the way down. What's the lowest point right here? So on the y-axis, that's 0. So it actually goes between 0 and 6 on how tall it is. So 0 less than equal, y less than or equal to 6. Okay, I want to do one more. So here we go. So let's say my graph looks like this. I'm going to draw a line over so you can kind of see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. We'll say that's 7. Okay, so let me zoom in a little bit. Let's look at the domain and the range. How wide is it? Well, it starts here at 0 and it goes all the way over to 7. So 0 less than or equal to x less than or equal to 7. The range, how tall is it? It goes all the way down to 0 and all the way up to 5. Less than or equal to y, less than or equal to 5. Okay, so what questions do you have on domain and range? If we're doing this together, you can raise your hand and ask me, or if you're doing it on your own, you can pause your video, raise your hand, and I'll come over and talk to you. Alright, the next one I want to do is, what if I give you an equation? What if I say f of x equals 16 minus x squared? And I ask you on this, what's the domain and what's the range? Okay, when you have one like this, really and truly the easiest way to do this is to get your calculator and let's graph it. So let me turn my calculator on. And let me put in here 16 minus x squared. Now you can use Desmos on this as well. I'm just going to use it here. I'm just going to hit graph. I'm just going to see what the graph of this looks like. Okay, so if I were to graph this over here, judging from what that other graph over there looked like, my graph looks like this. Okay. Where's the vertex? Well, let me look. I'm going to go to second table, and I'm going to look up, and you know what it kind of looks like here. Look at all the doubles going in. On Desmos, you could just touch it, but 12, 12, 15, 15. So 0, 16, if you look, that's where all the doubles are. So 0, 16 is where my vertex is, so that vertex is at 0, 16. So if I want to look at this and figure out, oh, what's the domain? Well, you know what? These arrows are dead giveaways. It's like, oh, yeah. There's no boundaries, so it's all real numbers for the domain. Okay? But the range, if I look, it has a ceiling up here that it hits, and then after that it just kind of goes down here for forever. Okay? How high does it go? It goes up to 16. Okay, so that would mean that my y value has a boundary of 16. Is it bigger than 16? What are values bigger? 17, 18, 19, 20, 21, 22. It's not up here. It's down here. 15, 14, 12, 11, 10, 9, 8, 7, 6. It's going down, so it's less than or equal to. Okay? pay attention to that. If you have a function like this, your domain's going to be all real numbers, and then you can figure out what your y value is from there. Okay, erase your board. Let's do another one. Let's do this. Let's take x, y, and I'm going to make a t-bar on this. We're going to do -4, -1, 0, 3, 4, and 5. Then I'm going to have 75, 21, 11, 5, 11, 21. Okay, here's the question. Let me move all this out of the way. I want to know what's the vertex. I want to know what's the vertex. What's the axis of symmetry? Vertex, axis of symmetry. Okay. And then I want to know, I think that's pretty much, oh, I want to know what the zeros are, if there are any. I don't know if there's actually any on this one. I may have messed up on that one. Okay. So when I look at this, can I say that my vertex is 5? Because I noticed 21, 21, 11, 11, 5. The answer is no. When you're given a table, if these are not in order, you cannot assume that that is your vertex where it looks like. You have to do a quadratic regression. So let's go to Stat, Edit. Let's put these in. So once again, you cannot assume that that's the vertex on a table. If these, see how it skips around? It skips 2 and 3 here, and then it skips 1 and 2. You can't assume it works, so you got to go back and put them all in. So we're going to go in here, put these in. Again, if you're just watching me do this, that's fine as long as you understand how to do it. Otherwise, you really should do it yourself. Okay, so I'm going to put those in. I'm going to give you just a second to finish putting them in yourself. We did Stat, Edit, and now we're going to do Stat, Calculate. Sorry, my room's cold. I'm going to put a jacket on. Okay, so I'm going to go back to Stat, and I'm going to go to Calculate. I need to do a quadratic regression. Okay, so here it comes. So there it is. So that means, set this to the side, I'm going to write my equation. My equation is y equals 2, so 2x squared. B is -8, -8x, and C is 11. Okay, so there's my equation. So once I know that, I can go to y equals, and I can plug that in. So 2x squared, and if I had stored it, I wouldn't have to type it in, but it's pretty easy to put it in. So let's go here. Let's see if we can figure out the, it's kind of, it's trying to make it darker. Let me just zoom in on it. Okay, let's see if we can find the vertex. Do you see it? Yeah. You can see 35, 35, 21, 21, 11, 11, 5, 5. So 2, 3 is the vertex. Okay, so what's the vertex? It's at 2, 3. So it's definitely not where it looked like it was on here. Axis of symmetry. Remember, the axis has the letter x in it. So it's x equals, what's my x value? It's 2. The zeros. Let's see, I don't know if we're going to be able to see those. So let's plug it in and let's see. All I did was hit graph. Oh, okay, I can see the zeros. The zeros are where you cross the x, oops, sorry, are where you cross this line. I don't cross it at all. If I don't cross it, then there are no zeros. So there are none. Very good. So when you have a table, you've got to do a quadratic regression to get your equation, then you can see your vertex. You cannot see your vertex just by looking at it. All right, let me erase. Ask if you have any questions, ask now. Otherwise, hold on. Okay, if I give you a graph, and that last one kind of answered this question already, but if I give you a graph and I say, what are the zeros? And I'm going to write that word down so you hear what I'm saying. The zeros are the same thing as the x-intercepts. So if I ask you what the zeros are, they're the x-intercepts, right here and right here. Now, the zeros could be here. I could have a parabola where it doesn't ever cross here. And in this situation, there would be no zeros. There's not any. There could be a situation where your parabola comes up, touches the graph, and comes right back down. In this situation, there's only one zero. There's only one. So I could have 2, none, where it doesn't cross it at all, or I could just have 1. And again, it's just a point, whatever that point happens to be. So let's take this and let's graph this. What would the x-intercept be? What would the zero of this quadratic be? Well, when you look right here, it's touching at 3. So the zero would be at 3. You could also write it as an ordered pair, which is over 3 up 0. Okay, you could write it like that too. Either way you want to write it, it doesn't matter to me, as long as you understand what the zeros are. Zeros are the x-intercepts. Okay, yeah, we've already done one like that. Okay, let's talk about transformations. Let's start with this function here. What do we call this function? This function is called the parent function. We do transformation on this function all the time. So if I give you g of x, and I say it's 2f of x, okay? A lot of you will say, okay, well 2 is bigger than 1, so that means it's a stretch, right? The question is, do you understand when you say that, what that means? So here's what I'm going to do. I'm going to draw it, and I'm going to put my parent function right here. If I multiply that parent function by 2 and stretch it to get more narrow, that graph would look like this. It would be inside, stretched more narrow from the other one. So this would be a situation where this 2 is on the inside. It stretches it. Okay. Let me get my, I have another marker floating around here somewhere, but it's green. I don't know where it went. Oh, green marker, where did you go? Okay, I'll just use, oh, it went down here on the floor. I found it. The flip side of that, let's do another one. Let's do h of x, just another function, equals 1/2 f of x. Okay, so this time I'm multiplying by 1/2. It's between 0 and 1. It's a fraction. So on this one, we call this a compression, or it's compressed. When you compress a Coke can down, it gets wider. So when I compress my graph down, it's like I smush it down, and it gets wider. So this one would be h. So if I were to graph these or ask you questions about a graph, and I said, which one of these models 1/2 f of x? Well, you would say, oh, the green one. Which one models 2? It would be the red one. Okay, so that's just kind of in a nutshell, like transformations when you're just looking at them. So let's talk about this. If I take f of x, or we're going to say it's x squared. If I take g of x, and I say it's -2 f of x plus 3. Can you tell me what transformations happened? There are 3 actually. The negative reflects it, makes it go across the x-axis. The 2 is bigger than the number 1, so remember that's going to mean it's going to take my parent function and it's going to stretch it more narrow. It's going to make it go up and be stretched, a vertical stretch. And the plus 3 on the end is not with the x, so it's moving on its own. It's just moving up and down, so it's going to say up 3. Okay, so that is a vertical transformation. Let's try another one. I'm kind of looking on my cheat sheet here to see what all I've got. What about something like this? What if g of x equals -x minus 5 squared plus 2? Okay, there's 3 transformations here. All right, the negatives are always easy because those just reflect. They flip it across the x-axis. The 2 on the end is always easy too. That makes it go up 2. Here I'm moving with the x. I'm in a relationship with the x. So it says it's -5, which would be going that way to the left, but I know it's line and it's actually going the opposite way. So it's going to the right 5. All right. Let's try one more. What if g of x equals 3f of x minus 4? Okay, think in your head what you think happened, and I'm going to tell you. There's 2 transformations. The -4 moved it down 4, and what did the 3 do? 3 is bigger than 1, so it's going to be a vertical stretch. If this is bigger than 1, then it's a stretch. If it's a fraction between 0 and 1, then that is when we say it compresses or it gets wider. Either way you want to say it. All right. Okay, one of the harder ones on the test today, probably the hardest one really. I'm going to give you a function. I'm going to write it as y, I think. I'm going to say y equals 2 times x minus 3 squared plus 4. 2, 3, 4. This is vertex form, and I want to go to standard form. Now, I know a lot of mistakes can be made in the math that goes involved with that. So here's what I'm going to do. I'm just going to say, okay, you want it in standard form? I'll put it in standard form. Let's take this and let's put it in our calculator. So we're going to go to y equals, and we're going to put 2 parentheses x minus 3 parentheses squared plus 4. Okay. I'm going to go to second table. I'm going to see if I can find that vertex. Oh, my eyes. Let me zoom in. I got my contacts in. They're kind of getting tired and dry. Okay, there it is. You see it? 3, 4. Right here's my vertex. You see all the numbers? Okay, so let's take 3, 4. We need to do a couple above it and a couple below it. Just a few. You don't have to do all of them. So we're going to do 6 and 12, and then we'll do 6 and 12 over here. Okay, so what did we do? We have that big long equation. It wants us to put it in standard form. And maybe you're like, what does it mean standard form? Y equals ax squared plus bx plus c. There's a lot of math that goes involved in doing this. It's not difficult, but there's a lot of spots for error. So we just took this, we put it in our calculator, and we got a table. Let's do this. We're going to go to Stat, Edit. Let me clear all this out. And we are going to plug in our table. 1, 2, 3, 4, 5, 12, 6, 4, 6, 12. I'm going to go back to Stat, Calculate, and I'm going to do a quadratic regression, number 5. Enter, 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 enter. Now I want you to look at what it gives me. It gives me this equation here. It tells me that a is 2, so 2x squared. It tells me that b is negative 12, minus 12x. And it tells me that c is 22. There it is. You wanted it in standard form? There you go. Now, could I have worked it out? Yes. To work this out, if I wanted to do it mathematically, let me just come down here and show you just kind of how this would work. You would do 2 x minus 3 times x minus 3 plus 4. You would distribute here, 2 across the top. Remember how we did 2 across the top, 2 across the bottom. Multiply this out, get your answer, multiply it by 2, and then add 4. That's really fast how to do it, but I just think if you get this and it wants standard form, which is this, okay, let me create a table, punch it into my calculator, do a regression, boom, there it is. No room for error when you do it that way. Okay, so let's see. I've done standard form. We've done transformations. Last one I really want to show you. Sorry this is so long, but I just had so much I wanted to show y'all for the review. Okay, so here is my question. I've got this ball that I'm going to throw. And I know that the vertex of this is at 2.4, 10. Oh, you can't even see it. 2.4, 10. You know what? I'm just going to make that a little better. That is not a very good. That looks better. I want to know, where is this ball going to come down? Like, what's the x? What's the 0? Where is it going to land over here? I know it's a parabola. And you're like, So, I'm not going to make you think about it too long because our video is already 20 minutes long. I know that parabolas are symmetrical, right? So whatever's over here, I know it's going to come up. It's going to come down somewhere right here, right? The question is, what is that ordered pair right there? Here's what I know. The distance from here to here is the x, right? So this distance here is 2.4. What does that mean about this distance from here to here? Yeah, it's also 2.4. 2.4 and 2.4, 2 plus 2 is 4, 4 and 4 is 8. So that means this total distance is 4.8. From here all the way over to here is 4.8. 0. So if I give you something like this, and there is one like that, and it's harder because it's kind of a weird number right here, you just double it, and then you get that other spot over there. Alright guys, I hope that helps you with your test today. Thanks for watching.